Okay, so we're going to go over the solutions to the Chapter 3, Part 1 Test Retake Study Guide. This is very, very similar to what the test is going to look like with just some different problems. So let's get started. I went ahead and put questions 1 and 3 together because question number 3 references question number 1. This first quadratic function is in vertex form already. So the vertex is simply the coordinate point. We can see it in the problem already. This is the x value right here and the y value there. Although with the x, because we think transformations, we take the opposite of the minus 5 to be positive 5, and then the negative 8 just comes as it is. So on the graph, we're going to go to 5, negative 8. There's our vertex. And then the 3 in front, that is our scale factor. So how do we interpret the scale factor if our table of values for a quadratic function is 1 squares to 1 and 2 squares to 4? The scale factor 3 is going to multiply these y values. So I'm going to take 1 times 3, which is 3. I'm going to take 4 times 3, which is 12. So when I graph this, I'm going to count 1, but then up 3. And negative 1 also up 3. And then for the 2, we're going to go 2 up 12. So 1, 2 up 12. It's going to land right here at 4. On the same side right here. So our parabola looks about like this. Okay, using that parabola, we can answer question number 3. Problem number 1 has a minimum point or a minimum value because we've got the vertexes at the bottom right here. And its value is where we see it on the y-axis right there, its lowest point, which is negative 8. Okay, next question. We're doing the same thing. We got to find the vertex. We got to draw a graph. We just find the vertex differently. To find the vertex here, the x-coordinate is found with the formula negative b divided by 2a. And so the b is, in the function, the b is 2. So we got negative 2 divided by 2 times a, which is negative half. So that's going to be just positive 2 when simplified. To find the y-coordinate of the vertex, we have to take the x-coordinate and substitute it in for the x's. So negative half times 2 squared plus 2 times 2 plus 5. So that's going to be negative 2 plus 4 plus 5, which is going to be 7. So our vertex is at the point 2, 7. It's right here. The negative sign means that this function is going to open down, and the 1/2 means it's going to go half of our normal count. So 1 squared to 1, but we're only going to go half of that down. 2 squared is 4, but we're only going to go half of 4, which is 2. I'm going to skip to 4. 1, 2, 3, 4, which squares to 16. But I'm only going to count half of 16, which is 8. 1, 2, 3, 4, and down 8. So that's enough points to kind of establish our parabola. Okay, for this parabola, actually let's do domain and range. Forgot it was there. Domain for all quadratic functions is negative infinity to positive infinity. Range is the y values, and so it's going down without bounds. So we're going to start at negative infinity and it goes up to 7, and it stops increasing once it hits 7. So that range is tied directly into question number 4. We have a maximum value, because our vertex is at the top right here, and it hits the y-axis at 7, which is also the y-coordinate of the vertex. Okay, next problem. Find the zeros of the function by graphing. So we're going to go to the vertex, which vertex here is going to be +3, -4. Okay, so opposite of what's inside the parentheses with what's outside parentheses. So we're going to 3, -4. And then we look for any scale factor change, and there's none. So we can just do our normal 1 squares to 1, both directions, and 2 squares to 4, both directions. What we are looking for is the places where the parabola crosses the x-axis. And it crosses the x-axis at x equals 1 and x equals 5. Those are our zeros. Okay, next we are supposed to solve the quadratic equations. In part 1, we only have square roots and factoring. So I've tried to been kind of teaching you or training you that we should maybe use square roots whenever we see x squared and a constant. So we've got a squared term here and a constant term. So I'm going to go ahead and just move the 81 to the opposite side. And then we're going to take the square root of 81. Which gives x equals plus or minus 9. Just don't forget the plus and minus sign so we don't lose points there. We also have factoring as an option. So is it possible to multiply to the constant term and add to the middle term? We can do that with x minus 6 and x plus 4. And we just set these equal to 0. X equals +6. And x equals -4. Next one, the other time I use square roots is when I have this binomial, these parentheses that are squared, but I need to start by dividing the 2 off of the front. So 90 divided by 2, I'm going to have x plus 5 squared equals 45. Now we can take the square root of both sides. So I get x plus 5 equals plus or minus 45 is 9 times 5, and 9 square roots to 3, so we get 3 square root 5. And so subtract the 5, we get -5 plus or minus 3 square root of 5. All right, next one, it's a trinomial. I'm going to attempt to factor it. I'm going to have to use 2x times x to make the 2x squared. 5 is only going to be 5 and 1, and since we're adding to a negative, I know I need to use negative. And to get to 11, I want the 5 opposite the 2 to make 10, and then 10 minus 1 more is going to give me to 11. So we're going to have x equals +1/2 from that factor, and x equals 5 from that factor. Okay, last one's in this set. So number 10, I see an x squared term and a constant term. So I'm going to solve with square roots. 6x squared equals 249. Divide everything by 6. So x squared equals, I need to do 249 divided by 6. Stepping away for a calculator. That is 41.5. Okay, so that's going to be 83 over 2. I am guessing that I probably have a typo on this problem because I don't think I would have given you one that had a 2 in the denominator that's going to end up being the square root in the denominator. So I'm going to say take this problem off. Don't worry about that one. Okay, finally, over here, I noticed that all these numbers are divisible by 3. So before I attempt to factor, I'm going to divide them all by 3. Make it x squared plus 3x plus 20 equals 0. And then we can try and factor. So let's see, 20 is only 1 times 20, which doesn't make 3. It's 2 times 10, which doesn't make 3. And it's 4 times 5, which doesn't make 3. So I'm going to say we can't factor. I'm going to say we got another typo on this worksheet. I know we've completed part 2 of this chapter, which would include quadratic formula, but for part 1, we hadn't done quadratic formula yet, so we shouldn't have to use it. So I think I just messed up in writing that problem. All right, write a quadratic function in standard form, given it has zeros of 4 and negative 2/9. So I'm going to take my function from the zeros into the factors first. And we're just doing the opposite relationship of this sort of problem right here, number 9, where the sign of the 0 is the opposite of the sign of the factor. So here, the positive 4 is going to be the factor x minus 4. And the negative 2/9, well, the 9 in the denominator means we had 9x, and the negative 2 would have come from plus 2. Now we just need to multiply this out. So x times 9, right? We're doing this whole process. We're doing our distributive property or our FOIL steps. So we get 9x squared plus 2x minus 36x minus 8. So 9x squared minus 34x minus 8. Next one, write the quadratic function in vertex form that has its vertex at 8, 4, and passes through the point 4, 0, right there. So I know I've got some sort of parabola. That's not drawn very well. I'll redraw that. I know I've got a parabola that looks something like that, and of course it's going to do the same thing off the graph onto the other side. So let's start with vertex form. Vertex form is a times quantity x minus h squared plus k. The vertex goes in for h and k. So our point 84 is going into these two spots. So that's going to give me f of x equals a times x minus 8 squared plus 4. Now I need to figure out the scale factor. And the scale factor I can figure out by counting how far this direction have I gone by how far this direction. So I went horizontally a distance of 4. Now normally in your table of values for x squared, 4 squared should be 16. But I didn't go down 16, I only went down 4 units. So what do I multiply this by to get 4? The answer is we multiply by 1/4. So the value of a has to be 1/4. Now because that parabola is opening down, it's actually going to be negative 1/4. So I have f of x equals negative 1/4, and then the rest of this quantity x minus 8 squared plus 4. All right, last problem. Completely factor the expression. So I'm looking for common factors first. All these numbers divide by 5. So if I take a 5 out, I have 6x squared minus 11x minus 10. And now we'll try and factor. I always start with 3x and 2x. And then if that's not right, I'll try 6x and 1x. And I haven't actually worked the problem out yet, so I don't know what's right. We'll just see. 10 multiplying to negative 10 could be negative 1 times 10, or 1 times negative 10, or negative 2 times 5, or 2 times negative 5. Those are our options for multiplying to negative 10. Can we arrange them in such a way that we make negative 11? I think we can with that one. Putting negative 5 there, because that makes negative 15x. If I put positive 2 there, that makes 4x. And those together are going to be the negative 11x. So that is our complete factorization of that polynomial. All right, that concludes this set of practice problems. I apologize for those 2 problems that didn't work out. If you need some replacement questions, just come and let me know.